Okay, this is the question from the previous gate paper from the subject of communication system. Okay, the topic is related to the digital communication. Okay, here this question is given in the paper of gate 2003. Okay, here the question is given as a sinusoidal signal with peak to peak amplitude of 1.536 volts is quantized into 128 levels using a mid-rise uniform quantizer. The quantization noise power is. Okay, here the now see the solution for this one. Here in the problem given as the sinusoidal peak to peak amplitude is given, that is nothing but V peak to peak. This V peak to peak is given as 1.536 volts V. Okay, and the number of quantization levels L is also given, that equal to 128 levels. Okay, now we have to find out for this data the quantization noise power. That quantization noise power equal to QNP, quantization noise power, that simply is delta square by 12, where delta is the step size for this transmission system. Actually this given transmission system is pulse code modulation system. Okay, in the pulse code modulation system or in any digital communication system, the delta is, that is nothing but the step size. The formula for the step size is nothing but V peak to peak of a particular signal by L. The another formula for this one is, that is V peak to peak by, where L is nothing but 2 to the power of n, where n is the number of bits to represent this system. Anyway, here V peak to peak is given and L value is directly given. We can find out the directly the step size value. That V peak to peak is nothing but 1.536 and the L value is given as 128. Now the 1.536 by 128 is nothing but 0.012 volts. Here 1.536 volts V. Now the answer is 0.012 volts for this delta step size. Now we'll find out the quantization noise power, that QNP equal to delta square by 12, that is nothing but 0.012 volts whole square by 12. Okay, if we simplify this one, then we'll get, that is nothing but 12 into 10 to the power of minus 6 V whole square, that is volts square. This is the quantization noise power for the given data. Okay, here simply the V peak to peak voltage is given 1.536 volts and L value is given. The quantization noise power will be delta square by 12, where delta is the V peak to peak by L. We got 0.012 volts. Now if we substitute in the place of delta 0.012 volts square by 12, the answer is simply 12 into 10 to the power of minus 6 whole square. Okay, here the option is C, that is 12 into 10 to the power of minus 6 V square for this problem.